In Part 1, you will determine the momenta of two balls of approximately equal mass before and after they undergo a nearly elastic collision. You will compare the total momentum of the system before and after the balls collide. You will also compare the total kinetic energies of the balls before and after collision. Determine the masses of the two steel balls and record the values. The masses of the two balls should be approximately the same value. In this lab, the pre-collision direction that the incident ball travels down the track will be defined as 0 degrees. Directions counterclockwise from 0 will be defined as positive, and directions clockwise from 0 will be defined as negative. Angle the T-support bar counterclockwise or clockwise from straight out, so the incident ball will strike the target ball at an angle of between 10 and 80 degrees, or between -10 and -80 degrees. Place the steel target ball on the tee, and place the incident ball on the track beside it. Adjust the height of the tee so the two balls are level. Then, with the target ball still on the tee, release the incident ball from the top of the ramp. If the collision is level, the two balls will strike the floor at the same time. If one ball strikes the floor before the other, adjust the height of the tee and repeat this step. When the two balls strike the floor simultaneously, the tee height is correct. Measure the height of the top of the tee above the paper and record the value. This is the distance the balls will fall to the paper after they collide. Record the value of the local gravitational acceleration. Then calculate and record the time it will take for the balls to fall to the floor after they collide. The plumb bobs hang straight down from the positions of the balls when they collide. The bob closest to the table indicates the horizontal position of the incident ball at the collision. The other bob indicates the position of the target ball at the collision. Mark the positions of the plumb bobs to show the horizontal positions of the balls at the collision. Do not change the T-support bar angle after you complete this step. To determine the velocity of the incident ball prior to collision, you will conduct several runs without using a target ball. Release the incident ball from the top of the ramp. Carefully observe where the ball lands and place a carbon paper square carbon side down at that position. Release the incident ball at least 5 times, making sure the ball lands on the carbon paper each time. Move the plumb bobs out of the way and remove the carbon paper. The marks on the paper made by the ball should appear as a tight cluster of dots. Mark the horizontal path of the ball by drawing a straight line from the mark you made under the plumb bob of the incident ball to the center of the cluster of dots. Then measure and record the horizontal distance from the plumb bob mark to the center of the cluster of dots. This is the average horizontal distance traveled by the incident ball during the time of fall when it had a horizontal velocity equal to the pre-collision velocity. Put the steel target ball on the tee. Release the incident ball from the top of the ramp and let it collide with the target ball. Carefully observe where the two balls land on the paper and place carbon paper squares carbon side down at those positions. Put the steel target ball back on the tee. Release the incident ball from the top of the ramp. The balls should land on the carbon paper. Do this step at least 5 times. Remove the carbon paper squares. Mark the horizontal path of the incident ball from its plumb bob mark to the center of the cluster of dots that it made on the paper. Measure and record the average horizontal distance traveled by the incident ball after collision during the time of fall. Now mark the horizontal path of the target ball from its plumb bob mark to the center of the cluster of dots that it made on the paper. Then measure and record the average horizontal distance traveled by the target ball after collision during the time of fall. The direction of travel of the incident ball prior to collision was defined as 0 degrees. So record the value for the incident ball pre-collision direction of travel as 0 degrees. Using the protractor, measure the post-collision directions of travel for the incident ball and the target ball, and record the values. Record as a negative value the post-collision direction of travel for the ball that had a direction of travel clockwise from 0 degrees. Calculate and record the magnitudes of the pre-collision velocity of the incident ball and the post-collision velocities of the incident and target balls by dividing their average horizontal distances of travel by the time of fall. Then, calculate and record the magnitudes of the pre-collision momentum of the incident ball and the post-collision momenta of the incident and target balls by multiplying the magnitudes of their velocities by their respective masses. Now, calculate and record the magnitudes of the x and y components of the pre-collision momentum of the incident ball and the x and y components of the post-collision momenta of the incident and target balls by applying the set of equations shown. Because the direction of travel for the incident ball before the collision was defined as 0 degrees, the pre-collision y component of the momentum of the incident ball will be 0. And because the post-collision direction of travel for one ball will be negative and for the other ball will be positive, one ball's post-collision y component of momentum value will be positive and the other ball's will be negative. Add the post-collision x component values of the momenta for both balls to determine the total x component value of the momentum of the system after the collision. Add the post-collision y component values of the momenta for both balls to determine the total y component value of the momentum of the system after the collision. Record the values. Because the velocity of the target ball was initially 0, and the x-axis was defined to be coincident with the pre-collision velocity of the incident ball, the magnitude of the total initial momentum is equal to the x component of the initial momentum of the incident ball alone. Record the value of the magnitude of the total initial momentum. Apply the Pythagorean theorem to determine the magnitude of the total final momentum for the system. Record the value. Use the percent difference equation to calculate the percent difference in the magnitudes of the total momenta before and after the collision. Record the value. Calculate the kinetic energy of the incident ball before the collision and the kinetic energies of the incident and target balls after the collision. Record the values. Add the post-collision kinetic energies of the incident and target balls to determine the total post-collision kinetic energy of the system. Record the value. Subtract the pre-collision kinetic energy of the incident ball from the post-collision total kinetic energy to determine the difference between the pre-collision kinetic energy of the system and the post-collision kinetic energy of the system. Finally, using the percent change in kinetic energy equation, calculate the percent change in kinetic energy during the collision. Record the value. When you have completed Part 1, print your lab report and proceed to Part 2.